This video will be our introduction to the Neisseria species. We'll teach Neisseria with a unified theme centered around a film noir type detective TV series that we've cleverly called Noir Series to make it resemble Neisseria. In this introduction video, we'll be using the advertisement poster for this TV series to teach the common features shared between both Neisseria meningitidis and Neisseria gonorrhea. Then we'll use two separate scenes that take place within the TV show to cover the unique features of meningitidis and gonorrhea separately. Let's start drawing our poster. Okay, first things first, Neisseria are gram-negative diplococci. Know what else are shaped like diplococci that fit nicely into our TV series? Handcuffs. So we'll draw some bright red handcuffs in the title to remind you of both gram-negative and diplococci. For now, let's start with the identifying characteristics of Neisseria. First, Neisseria is oxidase positive, so we'll give our detective this snazzy blue ring, which adds a nice sting when he's punching crime in the face. So when you hear gram-negative diplococci, that should really be synonymous with Neisseria. So they may not tell you what it looks like under the microscope. Instead, they may go for the various ways to culture Neisseria. It has some unique culture requirements that we have to know, so we'll talk about those next. There are two main augurs that we need to know. First is chocolate agar. Neisseria species are unable to grow in blood agar. This is because they're inhibited by some of the lipids and other elements in the blood agar. But if you heat blood agar, it renders these inhibitors inactive, allowing Neisseria species to grow. This heated blood agar is known as chocolate agar, just as you'd imagine burnt blood would look like. To help you remember this, we'll have our detective holding a chocolate bar. That's his thing. He loves chocolate, and he's always eating it, even at the gnarliest crime scene. He's that cool. So our main character is actually a private investigator, and he works in Vice City. So like all private investigators, he has to write on the window what he does, maybe to remind himself. So we'll write Vice City Private Investigator. But notice we forgot to write the I in front of the word investigator. And because of this, if you look at the first letters of the signage, it spells VPN. And VPN is the special agar we need to know. It's enriched with vancomycin, polymyxin, and nystatin. That's the VPN. So the most important element of any successful TV series is having great characters played by stars. Well, our star is Thayer Martin, and he's playing Mac, the private eye. We chose to make the lead actor named Thayer Martin because it sounds like a celebrity's name, and it's also another name for VPN agar that examiners may use. The more important part to remember is our character, Mac, the private eye. We're using his name to tie in an important immunology topic about Neisseria. Do you remember what deficiency causes increased susceptibility to Neisseria species? Complement deficiency, specifically of C5 to C9. When patients are deficient in these complement factors, they're unable to form the membrane attack complex, or MAC. So that's Mac the detective. To help you remember that the complement deficiency is specifically C5 to C9, we're going to say that the show runs from 5 p.m. to 9 p.m., a typical slot for a primetime show. Though I admit 4 hours for a TV show is pretty long, but this show has a pretty complex plot and teaches viewers all about life, crime, love, and gonorrhea. So it deserves this slot. Alright, let's move on to some of the virulence factors of Neisseria species. First and foremost, Neisseria's pilus is a major virulence factor. Not only does it allow for attachment to mucosal surfaces, but it also has frequent genetic rearrangement. And because of this, the pili display antigenic variation, which makes it difficult for our immune system to target Neisseria and prevents any lasting immune response. To remember these pili or fimbriae with many antigenic variations, we'll give Mac the detective a bunch of pocket watch chains that are made out of different metals. These multiple colored fimbriae will help you remember why Neisseria is so good at evading our immune system. Finally, Neisseria produces an IgA protease, which is a protein that cleaves IgA at its hinge point. This is an important virulence factor because it facilitates survival along mucosal surfaces. We'll use a variation of the same IgA protease symbol we used in strep pneumo and stick this ACE in Mac's hat. This ACE is for IgA protease. Notice that the suit is actually a picture of an IgA dimer. Alright, and that's it for the poster and all of the common features of the Neisseria genus. Now click on over to the next two videos to watch Mac in action.